Welcome back, Hampshire chemistry students. Glad to have you all today. We're going to be discussing in this video some of the differences between weak acids and strong acids and how we represent them differently in chemistry. Okay, so let's start with a little bit of vocab here. Maybe we're stretching our brain muscles a bit. And we are going to be discussing a strong acid first, because these are the ones we deal with the most together in chemistry. And the way we describe a strong acid is that it's an acid that dissociates completely in solution. So I would hope that if you have a pen or pencil out with me and you are writing this down, if you need a quick second to pause, do that now. Okay? But when we're discussing dissociate, remember the word dissociate means to break down or break apart. Okay? So if I have some friends that aren't in chemistry or don't like chemistry, we know they're crazy people. So I would dissociate myself from them. I would let that relationship break down as it should. Okay? But in this case, we're going to be looking at how acids break down. Okay, so a very common example of a strong acid, one that we used a bunch together this year, was hydrochloric acid, or HCl. And the way that I would show this guy dissociating would that it would be breaking down into its two parts. Remember that all acids would break and create a H plus ion, okay, and whatever is left over, that negative anion, the chlorine minus. Okay. Now with a strong acid, every single HCl molecule is going to break apart and make H+. So let's say I started with like 0.05 molar HCl. That means that I will have exactly 0.05 molar H+, and also 0.05 molar Cl. Although we care mainly about the H+, because this is how we would calculate our pHs and other different important things in chemistry. Okay. But what we're going to be looking at now, though, now that we've discussed equilibrium more, is weak acids. Okay, so weak acids are a little bit different. Okay, it's not that they go to the gym less or they skip leg day, okay, except they are acids that do not dissociate completely in solution. So they do not break apart as entirely as a strong acid would. A very common example of a weak acid is going to be acetic acid, which has the formula HC2H3O2. Okay? This formula here is also better known as vinegar. And I can show this reaction breaking down, except one key difference here is that I'm not just going to have a single-sided arrow now. And because we're connecting this to equilibrium, this is going to have a double-sided arrow. Because we're in that weak situation, not every bit of the acid is going to be creating the H plus and whatever is left over. So in this case, we're going to have that H plus, and that's that H in front, and we're going to be left with the acetate ion as the minus, kind of like the minus from the chlorine up here, the C2H3O2. Okay? These components here are going to be constantly moving back and forth. It's not really deciding. It can't be as divisive, as it cannot dissociate as much as those strong acids. And we end up with kind of a back and forth. And so we need a way to represent this type of equilibrium. Okay? Normally in other equations we would use things like KEQ, but since we're dealing with acids, what we really want to use is a different type of constant called Ka. And the A here is standing for acids. And it's calculated and written just the same way as our KEQ was. And we're going to take the concentrations of our products and divide them by the concentrations of our reactants. So in this case, we're going to have H plus concentration on top, multiplying the acetate concentration. Okay. Those are our two products, and the reactant, the starting substance, was the concentration of the HC2H3O2. Okay. This is no different than we would write for our other equilibrium equations. Okay. We are just now associating them directly with acids. You can do these also with bases. Those are surprisingly called KWs, or no, not really. They are KBs, right? For bases, KB for base, but we're doing an acid. Okay, so you're going to look at some more examples of these in the homework and represent these mathematically and do some calculations with these. But if you need to, take a second to go back, check your vocab, make sure you understood what we were doing here and how I was able to write this Ka equation for our acids. Okay, otherwise, I'll see you guys in the next video.